How to find love. Hi, everyone. Today, we're going to use our desire for love to debunk the major concept behind the blueprint of a machine learning model. We are going to start with dimensions which describe the attributes characterizing the data used in machine learning models. If we think about finding love, such journey requires a little bit of effort from our part as well. Therefore, we can propose self-awareness, self-love, our discernment of people, and emotional availability as dimensions. Let's focus on self-awareness, to which the targeted outcome is reflecting on whether we could be a good, loving, and understanding partner to others. So, would we date ourselves? Stages. Data selection implies, well, as you guessed it, choosing what data to work with, or in our self-awareness journey, what experiences or behaviors to examine. A key issue to consider is pairwise correlation, or quantifying the strength and direction of the linear association between a pair of variables in a dataset. So, pairwise correlation advises us to reflect whether the same trigger is activated by apparently unrelated events or scenarios in order to effectively address it. Data cleaning implies removing irrelevant values, single value columns to drop, traits that don't change, like fears that are no longer active low variance columns, habits or patterns that don't meaningfully impact your relationship outcomes. Outliers, reactions on preventable events of rare occurrence, such as missing a flight, impute missing value or parts of yourself or your emotional history you haven't fully processed yet. Simple imputer, does this issue need healing? For example, blushing when you see a crush, or gracious acceptance? Feature engineering. Feature importance could describe how much certain traits, like communication or empathy, impact your love life. We can choose out of permutation feature importance, calculates the relative importance score applicable to any model we opt for. In self-awareness, the permutation feature importance could lead to trust, patience, empathy, graceful communication, understanding, and any other traits which may affect our ability to interact or bond to humans. RFE highlights features within the dataset which can be regarded as the most relevant in predicting the target variable. Are we loyal, trustworthy, kind? Do we show interest in others? Correlation feature selection. What impact might one feature have on the other? If we're good listeners, it's very likely to also be good communicators. Mutual information feature selection. Best with mixed data and nonlinear relationships, mutual information feature selection highlights how much one feature reveals of another. Interest and curiosity about other people is likely to increase our understanding and empathy towards others. Algorithm selection. We are trying to see how we can use self-awareness in our journey to find love. We are setting ourselves for a challenge we can address through both classification as well as regression. Classification transpires in every moment in which we ask ourselves if any event or dialogue is impactful or not. Is this triggering or not? Regression can be located in any moment in which we try to estimate the healed version of ourselves. How will I be when I solve my fear of confrontation? Now let's decide what the most popular algorithms may lead towards: decision tree maps, emotional decision-making paths, and how they unfold. Our emotional response to an event depends on the importance attributed to either the outcome or the factors affecting them. Rudeness from a total stranger is unlikely to impact us to the same extent as the one exhibited by our boss. When coming from our boss, it may further impact us if experienced in a moment of pressure or when asking for a raise. Random forest. Think of the extended impact one issue might have on our life. Fixing our confrontation difficulties will allow both improving our negotiation skills as well as our ability to set boundaries. Neural network mimics the brain, allows you to rewire old beliefs and take new leaps, e.g., what if I stop playing safe? Break away from our patterns. What if we took a leap of faith today, or we decide we don't have a type? GAN, generative adversarial network, implies working with two neural networks, a generator and a discriminator, that compete against each other to produce realistic data. Think of identity shift. Act like we're already there. Fake it till we make it. Behave like the person who has it all and do it right now. Define dataset, make classification. Categorize areas to improve, whether it's self-esteem, trust issues, communication, attachment, and so on. Make regression. How will the ready for love version of me behave like? Ensamples describe scenarios which activate triggers or highlight behavioral patterns or beliefs. Features resume key factors we can use as framework for self-assessment, such as our attachment style, love language, communication style, wounds, and so on. Informative highlight key triggers we would like to address and key traits we are proud of and would like to enhance. Noise describes issues debated on social media which have never been our concern. For example, content related to dating apps for people who never use them. Random state refers to the extent to which the response to one event, for example, experiencing rudeness and not let it affect you, might be replicated on another one. Train test split. Train on reflections over the response to various past experiences and test on future experiences. Model training model.fit implies learning from past emotional data. Prediction describes how you'll respond next time. Evaluate R-squared describes how much of the variance can I explain? Well, some stuff such as not oversharing or keeping a gracious attitude remain unchanged. But the degree of spontaneity, for example, is likely to be adjusted to our potential partner's response. When in the healing process, MSE penalizes large emotional errors, heavily being useful when you're making big leaps. MAE highlights when we're either still wounded and reactive. More forgiving, MAE is good when you're still sensitive. Classification report gives performance metrics like precision and recall. How often you're right or wrong about what triggers you. K-fold cross-validation tests your consistency across different life settings, such as work, friendship, romance, etc. If we met a person through our entourage, social events, our self-development courses, through our professional life, or any other setting which might transfer upon our behavior, would we be able to predict our response? Fine-tuning a result either unsatisfactory or too good to be true? Let's see how we can improve results. We need to optimize our model, which leads to the learning rate, the size to which we adjust the parameters of our model, and APOC, a full rotation of our training datasets. For applying learning rate in love, let's think of how often should new experiences appear in our life for us to correct a behavior or belief we want to shed? As for an APOC, it would imply revisiting all key moments to which we conclude we may respond in a certain way. But what about our training data? In our introspection, did we actually manage to identify all key moments that made us think and act the way we do? In machine learning, we deal with Gini impurity, or the frequency to which an element might be mislabeled, and entropy, which measures the level of disorder or uncertainty within the dataset. Gini impurity is found in misinterpreting the desire to trust someone before sharing an impactful event as fear of vulnerability. As for entropy, is this your true, authentic self, or you operate from peer pressure, trends, or cultural norms? When dealing with regression models, we may confront with the bias error. Oversimplified assumptions such as everyone fears rejection, or variance, over-customized behavior that changes too much depending on who you're with. Bias leads to underfitting while variance to overfitting. An undercutting model is too rigid or generic, doesn't capture your complexity. An overfitting is too reactive and adapts too much to specific situations. An ideal model has low bias and low variance. For that, we need regularization, which can be attained through the lasso and ridge methods. The lasso keeps only the most important traits. The ridge method keeps all traits but balances their weight. When do we use each? Go for lasso when we believe some predictors are truly important, such as the attachment style. Go for ridge when we have many predictors contributing to the outcome. Ensemble learning uses the strength of combined models to get us even closer to our desired outcome. Bagging implies separating the training data on different subsets and independently training various models on them. Results are combined through voting for classification or averaging for regression. In the case of self-awareness and love, subsets of the training data might include self-worth, patterns of interaction, capacity to reach rational conclusions, rather than overthinking or seeing the bad in others. An insecurity might affect any of the three. Bagging would therefore indicate its overall impact on our life. Boosting implies training models one after the other, fixing the errors produced by the previous ones. A combination of all models creates prediction. In our past examples, confrontation avoidance from random forest may put a different pressure on events from the decision tree, which highlight how we have to act on more than the self-esteem and communication styles. Stacking, stacked generalization, imply training different models and use their predictions as inputs for a final model. Why not go for reflecting on the holistic implications of one issue, just like in the random forest? Test new waters just like in neural networks, and do everything as a totally different person, just like in GAN.transform. If, through shadow work, we unravel new depths of our triggers and reveal one of the 5 wounds identified by Lise Bourbeau: rejection, abandonment, humiliation, betrayal, and injustice. Permutation, importance assesses the importance of individual features in a machine learning model by measuring how much the model's performance degrades when a feature's values are randomly shuffled. How much can we focus on one behavior or belief, whether positive or negative? Mutual information quantifies the amount of information shared between two random variables. Life and its lessons reveal more and more mirrors for self-discovery, confirming issues that we healed within, while highlighting others yet to be addressed. Mutual information highlights exactly how interactions and experiences teach us what we should work on next in our growth journey.